Hello viewers, today I'm going to talk to you about the upper eyelid anatomy, and this is a crafted model made in an attempt to help you understand the lid anatomy better. The lid is made up of two lamella, the anterior lamella and the posterior lamella. The anterior lamella consists of the skin and the orbicularis oculi muscle, and the posterior lamella consists of the orbital septum and the tarsus and the conjunctiva. Now, as you can see, the lid is divided into an orbital part and tarsal part divided into the superior palpebral sulcus, which is formed by insertion of the levator palpebrae superioris muscle. If I turn around, you will see that this part is known as the lid margin. Now, lid margin is the point where the skin meets the conjunctiva. The lid margin is further divided into two parts. The 5/6 part literally is the ciliary part, and the medial part is the lacrimal part, which is 1/6. This lid margin has various structures. It has openings of various sebaceous and sweat glands. It has lashes, which are arranged in 2 to 3 rows and replaced over 120 days. And at the lid margin, the skin makes a junction with the conjunctiva, which is the innermost structure of the lid. It also has opening for meibomian glands, which we're going to talk about later, which are present in the tarsus. Alright, now if I remove this, you can see the structure, which is the subcutaneous tissue. The subcutaneous tissue consists of elastic fibers, and it's a very loose area which is present beneath the skin. Now if I remove this, the next layer is an important structure, which is the orbicularis oculi muscle. The orbicularis oculi muscle is a large, flat, elliptical muscle. It expands out from the medial palpebral ligament, which is present over here, and you can see this is the medial part as I've made. The medial palpebral ligament, from where the orbicularis oculi muscle, it expands out and it attaches onto the lateral palpebral ligament by formation of a lateral palpebral raphe, which is an interdigitation of the fibers of the orbicularis oculi muscle laterally. Now, as this muscle expands out, it gets we have divided it into various parts. It has an orbital part, it has a palpebral part, and it has a ciliary part. Sorry, it has chipped out. The palpebral part is divided into two parts, the preseptal and the pretarsal. These names are given in accordance with the structures which are present beneath it, that is the orbital septum, and over here the tarsus. Alright, you can see small holes over here. These areas are actually made for the by the levator palpebrae superioris, which sends fibers, and they pierce the orbital septum, and then they pierce the orbicularis oculi, and then they come to attach onto the skin to form the superior palpebral sulcus. Now, if I remove the orbicularis oculi, the next structure in line is connective tissue, which is present beneath orbicularis oculi, and it contains the blood vessels and nerves for the lid. After removing this, you're able to see a big important structure which is known as the orbital septum. This orbital septum continues into the orbit in the form of periosteum and periorbita. Orbital septum is a firm structure. It gives framework to the lid, and inferiorly it is continuous in the form of tarsus, which is also a firm structure. Tarsus contains meibomian glands. These are basically yellow color looking glands, and they have openings, as you can see, small black markings over here, and these black markings represent the opening of the meibomian glands onto the lid margin. The lid margin, where they open up and they secrete sebum, which is an important contribution to the tear film. Now, you can see a structure, a red structure over here, which is the superior tarsal muscle. This is actually formed by the smooth muscle fibers of the levator palpebrae superioris. The orbital septum continues downward in the form of the tarsus, as I already told you. And this orbital septum lies posterior to the medial palpebral ligament. Here's the medial palpebral ligament. The tarsus attaches with the medial palpebral ligament. The orbital septum comes to lie behind the medial palpebral ligament. On the lateral side, The orbital septum lies anterior to the lateral palpebral ligament, but it lies posterior to the lateral palpebral raphe that was formed by the orbicularis oculi muscle. One thing that I had missed, a few fibers of the orbicularis oculi muscle are sent medially to attach with the lacrimal sac, which is present over here in the medial orbit in between the anterior and the posterior crests, lacrimal crest, and that is very much contributory to the relaxation and contraction of the lacrimal sac, which is an important action in the drainage of the tears. Okay, so orbital septum comes to lie anterior to the lateral palpebral ligament, but posterior to the medial palpebral ligament. Okay, the tarsus is a crescent-shaped structure. It's 10 millimeter high in the upper lid at the center, and then it tapers out. It attaches at the upper border with the orbital septum and medially to the lacrimal crest and frontal process of maxilla by the medial palpebral ligament, and laterally by the lateral palpebral ligament to the marginal tubercle on the orbital margin. In the tarsal plate, I've told you that there are meibomian glands which are nearly around 20 to 25 in number, and I've already told you that they open at the lid margin to produce meba. Alright, so now the next structure in line to discuss is an important one, which is the levator palpebris superioris. Okay, as we know that levator palpebris superioris consists of two parts, a muscular part and an aponeurotic part. The muscular part is nearly around 4 centimeter, and the aponeurotic part is nearly around 1 centimeter. So as the levator palpebris superioris originates from the inferior surface of lesser wing of sphenoid, it moves forward and comes to attach as an aponeurosis after piercing and descending into the orbital septum. Here's the orbital septum, it pierces, it descends, it comes forward, and it attaches in the form of an aponeurosis, making medial and lateral horns. These are expansions of the aponeurosis. And you can see the structure over here. This is the superior tarsal muscle, which is formed by the smooth muscles of the levator palpebris superioris. The superior tarsal muscle, it actually originates from the inner surface of the levator palpebris superioris. This structure, after making its insertion over here, it is actually responsible for the elevation of the lid, and it's a very strong muscle, and dysfunctioning of this levator palpebris superioris results in ptosis. The innermost structure is the conjunctiva. Conjunctiva, is a mucus layer, and it is highly vascularized. It forms the innermost structure of the eyelid, and is the posterior part of the posterior lamella. The conjunctiva that lines the lid is the palpebral conjunctiva, and then it folds upon itself, like it would go like this, to cover the eyeball. And then that part which is between the lid and the eyeball, that is the fornical conjunctiva, that will come onto the eyeball, will be known as the bulbar conjunctiva. I hope you were able to understand it good. Just one last part. You can see these small extensions. These are actually extensions of the levator muscle, and this is what I told you earlier about, that they'll pierce the orbicularis oculi, and then they'll finally come to attach onto the skin to form the superior palpebral sulcus. Thank you very much for watching the video, and I hope you like it. I hope I've been able to simplify the concepts of lid a little bit, at least. Please do let me know the weaknesses, the strengths of this video, so that I am able to make better grafted models. Thank you.